Alright, so the first question you missed was number 10. It was a wet deposition question. And basically, they're asking if you didn't have any precipitation, then what would have happened on that particular month. Okay, so if you go back and look at this data, actually, you don't even need to look at the data. I take that back. Just look in the beginning paragraph, very first couple sentences here. You have to have precipitation in order to get this wet deposition. So just based on that concept, you shouldn't get any deposition if there absolutely is no precipitation. So in that case there, we would expect the answer to be H, no wet deposition. Again, there's no precipitation to carry those ions out of the atmosphere and deposit them into the soil. Alright, and the next question you missed was, it was about a titration experiment, and they're asking about experiment 2, which solution was a titrant and which solution was the sample solution. So if you go back and look at what's going on here, we have experiment 2 is described up here, and they say experiment 1 is repeated except that acetic acid solution was used instead of the hydrochloric solution. Now in order to know, where those sort of correspond to, you're going to have to go back and look at experiment 1 quickly here. We have that the sodium hydroxide was slowly added to the hydrochloric solution, so the titrant is what you slowly add. Okay, so that's your sodium hydroxide. You're looking at dropping this in a little bit at a time to see when there's a color change, and this is the solution you're adding it to. So if you go back up here, they're saying experiment 1 is repeated except that acetic acid was used instead of the hydrochloric solution. So it looks like your titrant was kept the same, your sodium hydroxide, but instead of hydrochloric acid or hydrochloric solution, we're going to substitute that out for acetic acid. So it looks like on that one, your titrant's going to be the sodium hydroxide and your sample solution is the acetic acid. Experiments 1 and 2, the probe that was placed in the sample solution most likely did which of the following? Alright, now they mention a probe here. In the reading I recall, let's see, where was that probe mentioned? A probe that measures conductivity was placed in the solution. Okay, that's going to be a conductivity probe. Conductivity probes indirectly measure the amount of ions. Okay, and they basically do that. It's like a probe. I don't remember using these with you guys. We may have. It connects to the logger probe device, and then this connected to the computer. Okay, and basically on here there's a little electrode that comes down. It's kind of opening through here, and basically this thing passes electricity, and if it can actually conduct because of the presence of ions, you'll get a conductivity reading. Okay, so that's the probe they're talking about. It's going to pass the electrical current through a portion of that solution and detect how well it passes, how conductive it actually is. So J is going to be your best answer there. Alright, and then we move to, we have a problem set here. It looks like the first one you missed was 40. In study 2, the average sediment accumulation rate for site 2 was calculated using which of the following expressions? Now this one could be a little tricky, so I went back. I'm looking at in study 2, site 2. Okay. Now if you look closely here, this sediment deposited only goes up to right here. Okay. And so right there. Okay, let's see. Site 1 was 0.41, Site 2 was 0.37. So this is going to be your Site 2. Okay, so Site 2, we're looking at basically how much sediment deposited. Let's see, 18 centimeters. And the difference between 1954 and 2003, you're talking 49 years there. Okay, so to me that's going to be, let's see, 18 per 49. It's going to give me 0.37, I believe. Let's take a look here. In study 2, the average sediment accumulation rate for site 2 was calculated using which of the following expressions? Yeah, that's going to be our the rate of accumulation. How much accumulation did we get per the amount of years? Okay, 1954 to 2003, that's going to give us those 49 years, so we're looking at 18 centimeters per those 49 years, and that's how we're going to get that average accumulation rate. And then the last question you missed, you didn't miss a whole lot here, this is the last one. A little bit of a, looks like a physics problem of some kind. Based on figures 2 and 3, as the elastic modulus decreased, the percent elongation did what? Alright, so figures 2 and 3. Now you kind of have to combination these graphs together to understand this. I can see here in figure 2 that as my elastic modulus decreases, my percent glycerol by mass increases. So I'm going to have to use that information in the following graph up here. In other words, as my percent glycerol by mass increases, what does my percent elongation do as shown by the dotted line? You see percent elongation dotted line. So as my percent glycerol by mass increases, my elongation increases. So again, notice how we had to, this variable is not in this graph, so I had to make this relationship first. As my elastic modulus decreases, I know that my percent glycerol by mass is increasing there, so I'm actually getting more percent glycerol by mass as my elastic modulus decreases. And then I go up here and I say, okay, as my percent glycerol by mass decreases, increases, as my percent glycerol by mass increases, what happens to my percent elongation as shown by the dotted portion here? And that percent elongation increases. So based on that, the elastic modulus, as it decreases, the percent elongation is going to increase. So F is going to be your best answer there. Okay, good luck on your test on Saturday.